Have you ever wondered how forces and moments interact in the field of biomechanics? Well, the answer lies in the operations applied to vectors, forces, and moments. These operations break down complex biomechanical interactions into understandable components, allowing us to analyze the mechanical aspects of living organisms. Take vectors, for instance. These arrows in space represent quantities like forces or displacements that have both magnitude and direction. Adding or subtracting vectors gives us a resultant force or displacement. Scalar multiplication, on the other hand, changes a vector's magnitude without altering its direction, showing how different magnitudes of forces can impact a system. Then we have the dot product, a handy tool for calculating the work done by a force or finding the component of a force in a specific direction. There's also the cross product, used to calculate moments or torques around a point, giving us insight into the rotational effects of forces. Now, let's shift gears and discuss forces. Biomechanics often requires us to break down a force into its components, a process known as the composition of forces. This is especially relevant when analyzing joint forces during movement. The resolution of forces or combining individual force vectors helps us determine the resultant force. An equilibrium? That's a state we analyze to understand how the body maintains stability during activities. Moments, or torques, also play a critical role in biomechanics. The moment arm, or lever arm, is the perpendicular distance from the line of action of a force to a reference point. This is key to understanding joint torques. To calculate the torque or rotational effect of a force, we use the principles of moments. Consider the concept of a couple, a system of two equal and opposite forces acting at different points. This creates a pure moment without any linear acceleration. And in order to understand the mechanics of movements, we need to ensure equilibrium not only for forces but also for torques around joints, a process called torque balance. So there you have it. These operations and concepts are the building blocks biomechanists use to analyze and interpret the mechanical interactions within the human body or other living organisms during various activities. They allow us to understand how our bodies move, how forces affect us, and how we maintain balance and stability. Fascinating, isn't it?